In this video, we're going to look at how to multiply rational expressions. So a typical question would be something like this. Multiply x minus 9 over 2x plus 4 by x plus 2 over x plus 3. And there's a sequence of steps that you should follow when multiplying rational expressions. First, you need to factor all the denominators and all the numerators as fully as you can. Then you want to cancel any factors that are common to both a numerator and a denominator, and multiply across. Finally, you want to write restrictions by looking at the factored but uncancelled denominator, as we did when we were simplifying single rational expressions. So let's take a look at what that all means. Here's that same question again, and now we've got the steps up here to the right. So the first step is factor all the numerators and denominators fully. Notice that x squared minus 9 is a difference of squares, so it can be factored to x plus 3 times x minus 3. And 2x plus 4 has a common factor of 2, so it can be factored to 2 times x plus 2. The right-hand side rational expression can't be factored any more than it already is. Now notice, you might look at this and think, well, there's an exposed plus here, so it's not fully factored, and I wouldn't be able to cancel using this, but you actually can cancel. Notice that if you put a brackets around it like that, it hasn't changed anything about this at all. There's nothing else here, so putting the brackets is sort of an empty gesture, but it reinforces for us that this is fully factored and therefore it's cancelable. Same thing with this x plus 2, so you might want to put it in brackets like that to remind yourself. Now we look for any factors that are common to a numerator and a denominator, and as we said, we've got a x plus 2 there and an x plus 2 there, one in the denominator, one in the numerator, and we can cancel the x plus 3's in the same way. Now, every time we've canceled, we've been dividing by x plus 3 or x plus 2 as it is, which means that all we've got left in those spots are 1's. So if we multiply across now, in the numerator we get x minus 3 is the only thing that's left, and 2 is the only thing left in the denominator. So that's our answer. However, we still have to write restrictions. So remember that we write our restrictions by looking at the factored but uncancelled denominators. So we have to look back at this step, not this step. If you look at this step, you'll say, well, there's nothing that would make this denominator 0. It's always going to be 2, so there's no restrictions. But that's not correct. You have to look back at this step to write restrictions for the whole question. So what would make the denominator 0? Well, from here, if x plus 2 were equal to 0, in other words, solving for x, if x was equal to negative 2, this would become 0, which would make that denominator 0. So we can't allow that. Therefore, we have to state the restriction that x cannot be equal to negative 2. Similarly over here, if x plus 3 were equal to 0, that denominator would be 0, and that would occur when x was equal to negative 3. So we can't allow that. Therefore, x cannot be equal to negative 3. So the restrictions, which we got from looking at the fully factored but uncancelled denominator, are x cannot be equal to negative 2 and x cannot be equal to negative 3. Let's look at another example. Here we've got x plus 2 cubed divided by x minus 2 times 3x minus 6 over x plus 2 all squared. So this left-hand rational expression is already fully factored, so we're just going to rewrite it. However, the right-hand one, you can factor the numerator by common factoring out a 3 like that. Now, again, we have an x minus 2 here in the denominator and an x minus 2 in the numerator, so those can be cancelled, leaving 1's there. We've also got two x plus 2's here, right? That squared means that it's x plus 2 times x plus 2, and we've got an x plus 2 cubed here, so we could divide both of those by x plus 2 squared. That would make that just 1, and would get rid of that 3. You'd only have 1 x plus 2 left. Now, multiplying across, you get 3 times x plus 2, or x plus 2 times 3, in whichever order you like, which if you multiply out and simplify is 3x plus 6. In terms of our restrictions, we look at our fully factored but uncancelled denominator, so at this step. So from this one, x cannot be equal to positive 2, because positive 2 minus 2 would be equal to 0. And from this one, x can't be equal to negative 2. So our restrictions are x cannot be equal to 2 or negative 2.